So y'all haven't seen the cuties in a while, but there's Zach. He's just chilling. And there's my mother-in-law's nightmare. His name is Bubba. You may be wondering why we need another division technique. You might say, man, I'm so good at long division now. Why do I need this other one? And the reason is because if you have something like x plus 1, something that does not have a number here in front, synthetic division is actually a lot faster. Now, if you do have something like, let's say, 2x plus 1 that you're dividing into a function, long division is going to be your best bet. So this is the case when you want long division. But when you have no number in front there, so you have like x plus 1 or x minus 5 or x plus 8 or whatever, synthetic division is going to be best. All right, and you'll see why when we learn it. But here's also another reason. Remember, we're still trying to find those zeros of these polynomials. We want to know where things cross the x-axis. So a little bit later in the chapter, you're going to learn something called the rational root theorem. And the rational root theorem is going to give you lots of options for roots. It's going to say it could be positive negative 1, could be positive negative 2, could be positive negative 3, could be positive negative 5, could be positive negative 10. And your job is to figure out which one out of those 8 is right. So the way you would do that quickly is to use synthetic. So that's another reason why you're going to want to know synthetic as well. Okay, I'm going to use this example, still trying to find if something is a factor. So remember, it's a factor if it goes in evenly. So I'm going to use this to teach you how synthetic works. So this function, if it were, since it says x equals 4, that means I want to know about the number 4, and it goes in this little box off to the, or like a half box off to the side. Now, if this were written, this factor of 4 comes from x minus 4 as a polynomial, like that. So the way we do that is that you could set it equal to 0, in which case x is 4. So I could give you the question two different ways. I could give you the divisor like this, or I could give it to you like that. Okay. Either case, you're going to put just a number in this little half box, and in this case, that number would be 4. Now, over here to the right, I'm going to take all of my coefficients. There are no x's involved. I want to take all the coefficients, and I'm going to write them out in order. So I have 1 goes with x to the third, negative 7 goes with x to the second, 16 goes with x to the 1, and then negative 16 would be my last lonely coefficient. So notice how it's all numbers. All right, and then what I'm going to do is leave some space and put a line in. And the way this works is you take the first coefficient and you drop it down, and then we're going to multiply and add, multiply and add, multiply and add all the way through this thing. So we're going to multiply 1 times 4, and that answer goes here. So I got the 1 times 4 from there. Negative 7 plus 3 is, negative 7 plus 4 is negative 3. Now I'm going to multiply again. 3 times 4, negative 3 times 4 is negative 12. And then I add straight down and I get positive 4. Multiply again. 4 times 4 is 16. Negative 16 and 16 is 0. This last number down here is where your remainder is. And that remainder tells you if it's a factor. So since we got a remainder of 0, this is a yes. 4 is in fact a factor of that polynomial. Now the way that we write our answers, because we will need to know this, is remember this 4 comes from x minus 4. Now this answer that we're left with down here, remember these are all coefficients. So we're going to take each coefficient and put it back into the function, except because we divided, we're going to start 1 degree lower than the thing that we divided into. So if that was an x to the third, we're going to use x squared. And then my next coefficient, this negative 3 here, becomes negative 3x, and then plus 4. So what we found is that this times this is equal to what we started with. Let's try some examples. These are going to be on page 89 in your workbook. So number 5, what we do is we take x minus 2 and set it equal to 0. That gives us a positive 2. Then we're going to take our coefficients and list them in order. So this will be 1x squared minus 10x plus 2. We're going to draw our line. Now to solve this, we're going to drop the 1, multiply and add all the way through to the end. 1 times 2 is 2, negative 10 and 2 is negative 8, negative 8 and 2 is negative 16. So that leaves me with negative 14 as my, remember this is the remainder spot. Okay, so to write this answer, since we're dividing, what we want to do is say what we're left with after we divide. These numbers here are just the coefficients of our answer. So our answer is going to be 1x, because my leading degree was 2, I'm going to start with 1 below that. So it'll be x to the first, and then minus 8. And then what I'm going to do with this remainder is I'm going to take it and put it over what I divided by. So that's the same as it was in long division. All right, so that's what my final answer looks like in this case. All right, let's try another one in number 6. So we're going to take x plus 2, set it equal to 0, because remember we only want numbers for synthetic division. And then we want all of our coefficients. So we have 1x to the third plus 4x squared plus 6x plus 4. Only the numbers. Then we're going to drop 1. 1 times negative 2 is negative 2. 4 and negative 2 is 2. 2 times negative 2 is negative 4. Oh, we got a lot of 2's here. 2 times negative 2 is negative 4. And so in this case, I actually end up with a remainder of 0. So again, what that means is that x plus 2 is in fact a factor of this polynomial. All right, and again, we want to write out our answer using 1 less degree than what the question was. So this will be 1x squared plus 2x plus 2. And that's it, 'cause we have a 0 remainder. In the event of number 7 happening, we can still set up our divisor. That will be x plus 3 equals 0, which would be negative 3. And what's going to happen here, though, is I'm missing a lot of terms between x to the third on down. So I'm going to start with 2x to the third. My x squared spot, I need to put in a 0. My x to the 1 spot, I need to put in a 0. And then I'll have minus 54 here. All right. And so again, what I'm doing is I'm using placeholders for any terms that are missing in descending order. And now what I want to do is just do the synthetic. So I'm going to drop the 2, and I'll have 2 times negative 3 is negative 6. This gives me negative 6. Negative 6 and negative 3 is 18. 0 plus 18 is 18. And then 18 times negative 3 is negative 54. So that will give me negative 108. Ooh, that stinks. Okay, again, that is your remainder. So to write the final answer, it will be 2x squared minus 6x plus 18 minus 108 over x plus 3. Another nice thing about synthetic division is we can do something called the remainder theorem, which means what the theorem says is that if you take, if you want to know what f of a number is, let's say f of 3. So f of any x, if I divide that into a polynomial, the remainder that I get is actually the answer for f of 3. So what we would normally have to do, for instance, in number 13, what we used to do is we would take f of 2, since it's saying it wants x equal to 2, and you'd plug it in for every number. I'm sorry, for every x value. 17 is 2, and then you'd have to work order of operations. Well, the remainder theorem says that I can take that x value and I can work out synthetic. So I have a negative 3x to the third, 4x squared minus 17x and minus 6. I say that to myself so that I know that I have all my coefficients in descending order. And then when I work synthetic, I'll get negative 4, negative 21, negative 42, and negative 48. So what this says is that f of 2, if I were to solve this out, is just going to give me negative 48. So the remainder that you get out is what you can find it easier if I'm asking for f of 2, for instance, by just finding the remainder once I divide. Okay, and that's all that means. So we'll try another one, like number 14. We're going to take negative 1 and put it in the half box. We want to be careful here because I already see that I'm missing an x to the third. I'm also missing x. Almost missed that one. Okay, so I'm going to use negative 1 x to the fourth. I have no x to the third. I'm going to put 0. 1x squared, no x, and then 4. All right, and when I drop these down, I'll have, let's see, 1. Be careful all these 1s here. 0, 4. So my remainder is 4, which means the answer to f of negative 1 should be 4. Now this one should be easy enough. We could probably find this real quick. Just to verify, let's do that. If I plugged in negative 1 here, I'd get out negative 1 plus 1 plus 4. Negative 1 plus 1 plus 4 is 4. So in fact, I've shown that that is true.